Hi friends, welcome to JS Frameworks. So today we'll be taking a look at how we can integrate Webpack 5 into an Angular 11 application. Angular 11 provides an option to use Webpack 5 as an opt-in. So for using that, we need to select the manager as yarn. So for doing that, we need to add the package manager as yarn in the CLI. Once we make yarn as the default package manager, then we can go to the package.json file and we need to add the resolutions property in which we need to give the Webpack version as 5. So now we are ready to use Webpack 5 in our application. So now let us take a look at one of the features which was introduced in Webpack 5, that is the module federation. The main concept of module federation is that there can be two types of modules. One is the local module and the remote module. The local module is the bundle which is part of the current build, and the remote module is not part of the current build. The local module will be able to load chunks of code from the remote module or the container. This can be done lazily and the runtime. So this helps in preventing the dependency between the modules and also helps in developing and deploying the modules independently. So this will be a key concept in building micro frontends which work on the same principles. So now let's see how we can implement module federation in the Angular 11 application. So since Angular CLI does not provide the feature to extend the Webpack configuration, we need to use a custom builder. So here I am using the custom builder called ngx build plus. So this provides the capability to extend the Webpack configuration. So now we need to replace the default builder in the Angular JSON. So in the Angular JSON, actually I have created two separate Angular applications. One is the micro frontend. So this will be the remote container which we'll be using in our demo. And the main application is the source where we have created as a local application. So that is named the ng module federation. So now we need to replace the builder here. So I am replacing the builder in the build step as well as the serve step. So we need to do it in the other application as well. So I have assigned a different port for the micro frontend application. So that's a port 4300. The source from which the extra Webpack configuration needs to be loaded, we can provide it here, both in the serve as well as in the build steps. Now let's create a file in the root folder. I have created an empty file as of now. Similarly, we can add the details of the configuration file for the main application as well. So both in the build and the serve steps. And let's create an empty file for the same. So now let's start building the Webpack configuration. So first we will start with the output key value in the configuration, and here we will give the unique name. So why this is needed? So since module federation can load multiple Webpack runtimes into our application, this can result in conflicts in the Webpack runtime. So we need to identify each with a particular name. So by default, when we run an application, if you check, you can see that the default Webpack runtime will have the name as Webpack chunk, along with the name which is taken from the package.json. So if we go and check the package.json, you can see that we have provided as ng mode federation. So it will be the name provided to the Webpack runtime. The Webpack runtime will contain the details of the various chunks which are currently generated in the application. So as you can see, the polyfills, the vendor and the main. Now I have restarted both the applications using the new Webpack configuration. So this is our host application which we saw earlier. So now if you see, you can see that the previously loaded runtime that is not available since we gave a unique name for that. So that has been renamed to Webpack chunk host, and this is our MFE application. So here it has been given a unique name as Webpack chunk MFE. So now let's import the module federation plugin into our configuration files. So both in the MFE as well as in the host tab. And also let us add the plugins. And here we can provide the new module federation plugin. We can add that in the MFE also. So now let's take a look at the source code of the module federation plugin. So if you go into detail, you can see that there are three plugins inside the module federation plugin. One is a shared plugin, one is a container plugin, and the container reference plugin. So the shared plugin basically handles all the libraries which can be shared between the multiple bundles. So for example, the Angular libraries, the Angular core, Angular common. Since both of these are basically Angular applications, these can be shared across the modules. So that is the role of the share plugin. And the container plugin, basically this is the interface or the plugin which is used by the container or the remote module so that it can expose its modules or the components so that it can be accessed by the local module. And the container reference is used for configuring the remotes which can be accessed by the local module. First, let us take a look at the share plugin. So one of the main options that is used in the share plugin is the shared option. So the shared can be either an array which contains the list of libraries which can be shared between the modules, or it can be a complex configuration object like this. So inside this shared object, we can give the name of the library and whether it needs to be a singleton so that only a single instance of it is available across the modules. And also we can set the strict version flag as true. So like there can be multiple versions of this library in the different bundles. So in case there are incompatible versions, then the Webpack will result in a failure in case this flag is enabled. So it is always better to use libraries or share libraries which have the similar compatible versions. So let's add it in the host application as well. Now let's see what happens. So now I have restarted both the applications and you can see that the Angular core libraries are getting generated as lazy chunk files in both the applications. Now let us go to the host application and refresh it. Now you can see that an error is thrown by the main application. This is because like in the main.ts of our host application, we are trying to eagerly load the Angular libraries. So in order to fix this, we need to create a new file called, you can give any name. For example, I give a bootstrap.ts and you can copy the contents of that into this file and inside the main.ts, you can use a dynamic import to load the bootstrap file. Now let's go and refresh the host application. So now you can see that the application is working as expected. Now I have repeated the same steps for the MFE application as well, and when we refresh the MFE application, it also gets loaded as expected. So if you check the Webpack runtime for both the applications, you can see that the new lazy loaded chunks have also been added to the runtime in both the applications. So since we have not started using the actual container concept here, so these will exist as independent applications and the chunks will be duplicate in both of them. So now let's take a look at the second plugin, that's the container plugin. So the options which are used inside are the name, file name and the exposures. So now let's add these properties in our MFE application. So I have given the name as MFE. So this will be the name of the container which will be created for the MFE application. And the file name I have given as mfe.js. So this will be the name of the file which will contain the extracted Webpack runtime of the container or the remote application, remote module. And exposes, it can either be an array or it can be a object. So here we can define the name of the module, uh, like that's a shorthand notation, and you can give the actual module which is need to be exposed. So here I am planning to expose this particular module. So it contains a router module with 4 child, and it contains the path home and the lazy component. So inside the lazy component, we check the HTML. It's basically this page. So I am planning to expose this particular uh, page, which is part of the lazy module, so that any local module can access it remotely. So I have restarted the MFA application, and you can see that two extra bundles have been added. One is the mfe.js, which is the Webpack runtime for this particular container, and the actual module which we have exposed. So it will be created as a lazy chunk file so that it can be lazy loaded by any other module. Now let's take a look at the third plugin, that's the container reference plugin. So this will be used by the local module which will remotely access the remote module. So the options which we need to pass is the remotes. So this also can be an array or an object. So here I have given the name of the remote container as MFE, and this is again a short name, and this is the actual name of the container and the file from which that container needs to be loaded. So I am giving the URL for the MFE application, that's 4300 and mfe.js. So now we have added all the required configurations. Now we can go to the app routing module inside our main application, and I am adding this route here. So I am adding a new path lazy, and I am adding a load children in which I am trying to dynamically load this mfe/mfe module. So this mfe is the short name which we provided for the remote here, and the mfe module is the short name which we provided in our mfe webpack configuration. So ideally we are trying to load this lazy module.ts. So here you can see there is some typing warning. So you need to add a d.ts file, and you need to declare this as a module. So now you can see the error has gone away. Now let's restart the application. So I have restarted the application. Now what I am trying to prove in this demo is that by default the home component will be loaded, and once the home component is loaded, we'll be clicking on the home text and it will be navigated to the lazy loaded module. So let's go to the application. So as you can see, the home component is loaded here, and if you check the Webpack chunk, so host is there, as well as the new MFE chunk is also created here, which has been loaded from the remote module, and you can see the name here, MFE. So when you click on this, okay, you can see that an error has occurred. So this is actually a bug which can be fixed by adding a configuration in the MFE Webpack. So we need to turn off the runtime chunk. So runtime chunk produces a single Webpack runtime during the build process. So we are turning it off for now. We'll also add it in the host Webpack configuration. So now let's restart the application. Now I have restarted both the applications. Now let's go to the host application and refresh it. So let's click on the home icon, and you can see that the remote module has been successfully loaded here, and this is basically the remote module which is running on the different port. So our demo is a success, and let's see the Webpack chunks. So in the host chunk, you can see that only the bootstrap chunk is there, and in the MFE chunk, you can see that all the remaining the shared modules are present only in that chunk. So the share plugin is also working. And now let's see how we can import a component instead of a module from a remote application. So the first thing we need to change is in the MFE Webpack configuration. So I am changing that module to a component. So basically it will take the lazy component and expose it instead of the module, and then we will go to the home application, the host application, and we will add this piece of code. So basically what it does is it will dynamically import the MFA module, which will be this time actually a component, and we will be loading that lazy component here. And instead of creating a load children, I am giving a component here, and I am calling this method here. So you can see here that there is some warning like from TypeScript. So it shows that top level await is not allowed until the module and the target is changed. So let's go to the tsconfig and change it. The target should be is 2070, and this will be ES next. So now the TSR has gone away, but while trying to serve the application, it is showing an error like the top level await experiment is not enabled, and you need to enable this in the Webpack. So let's do that in our host Webpack configuration. I am adding this flag that says experiments top level await as true, so that top level await can work. So now let's restart the application. Now our host application has been built successfully. Now we need to make one more change, that is in our home component we need to change the route here, because we are no longer using the remote module, we are just using the path lazy. So let's go to our application. When you refresh our application, it comes to the home page, and I am going to click the home. Now you can see that the remote component has been loaded here, and the path has been changed to lazy. Disadvantage of this approach is that we are hard coding the location of our remote module here in the Webpack configuration. So this may not be available in the build stage itself. So we can do one thing: uh, we can move it as a script in the index.html. So for this, we need to add a type remote type var here, and you can remove this URL and just provide it as a key here and move it as a script tag in our index.html. And now let's restart our application. So our host application has been restarted, and when we go to our host application and refresh it, you can see that it is working as expected. So here we have introduced the script tag in our index.html. So like we can make it more dynamic by adding the script tag dynamically. So this will most likely be the case in actual scenarios. So for those purposes, we can make use of a npm module, the Angular Architects Module Federation. So this provides a lot of features which can be used for implementing the module federation in our applications. So if you go inside the code, you can see that they are doing exactly the same thing. Like they are creating a script tag and setting the source as our remote.js file. And once it is loaded, they will be doing something like this. So um, actually, in the window object of our application, you can find a object with the same name as our container. So you can call the get method here, and you can give the module name which we registered here. And if you do this, you'll get the Webpack loader. And actually, that's a factory function. If you call this, you will get the actual module, which is the lazy load component, the lazy component. So they are also using the same thing, but it's provided in a much more reusable way. So it will be really helpful for your development. So please note that the Webpack 5 is still under development, and it is not suggested to use this in production code. This is just for information. Hope you were able to get a better understanding of the Webpack 5 module federation and how it can be integrated with Angular 11. See you soon. Thank you.